Sometimes, it's what lies below the surface that reveals a hidden world of science. Roughly 3 billion years ago, a photosynthetic bacterium began releasing a gas that would soon become a game-changer for life on Earth. This chemical, initially toxic to almost every species, began to seep into Earth's waters and eventually filled the atmosphere, transforming it forever. That gas was oxygen. Over millions of years, as Earth underwent the Great Oxygen Catastrophe, nearly all life forms evolved to depend on this once lethal compound. But even today, certain oxygen-averse microorganisms, akin to Earth's oldest life forms, persist in isolated environments. While many thrive deep in the ocean, inaccessible to researchers, there are also a few rare and closer locations where these ancient life forms thrive without oxygen. One such place is nestled high in the Swiss Alps' Piora Valley, Lake Cadagno. Lake Cadagno is not just an ordinary lake. Formed over 10,000 years ago, it is one of about 200 meromictic lakes, which means it consists of two distinct layers of water that never mix. The top layer behaves like typical freshwater, safe for swimming and brimming with fish. But just 13 meters below the surface lies a dense, sulfurous layer completely devoid of oxygen, lethal to fish and other multicellular organisms. In most lakes, water circulates from top to bottom, ensuring oxygen reaches every part. However, meromictic lakes like Cadagno maintain a permanent separation due to the unique chemistry of their waters. Rainwater flowing from the surrounding mountains enters the lake through two distinct routes. Some water flows straight into the surface layer, while other streams seep into the porous dolomite rock, becoming heavy with salts like sulfate. This denser, salt-laden water sinks and gathers in the lake's depths, forming the toxic bottom layer. This anoxic environment is home to anaerobic bacteria, organisms that would have thrived before Earth's atmosphere became oxygenated. These bacteria feed on the sulfate-rich waters, releasing harmful sulfide gases. A particularly interesting resident of this layer is Chromatium occoni, a pink-hued photosynthesizing bacterium that uses sulfur in a process similar to how plants utilize oxygen. What's truly remarkable is the relationship between the two layers. The pink blanket of Chromatium occoni stays just below the upper layer, as it relies on sunlight but cannot survive in oxygen. This proximity allows small organisms from the oxygenated waters above, like zooplankton, to dip into the pink zone, feed on these bacteria, and return to the safety of the oxygen-rich surface. This dynamic exchange forms the base of the food chain, supporting the lake's thriving fish population. Lake Cadagno's unique ecology offers scientists a rare opportunity to explore life as it existed billions of years ago. The conditions at the boundary between these layers create microenvironments similar to those that might have been present during Earth's early days. When Chromatium occoni rises to the top of the bottom layer, the increased density forces the water to sink, pushing the bacteria back down, creating a phenomenon called bioconvection. This ancient process may shed light on how early microorganisms developed the ability to swim, and ultimately, how complex life evolved. Lake Cadagno's delicate, isolated ecosystem is a living laboratory, holding clues to the past and offering a glimpse into the early evolution of life on our planet. Its unique layers and the life they support make it more than just a natural wonder. It's a key to understanding Earth's ancient history. For more videos, please like and subscribe.